All right, let's dive into one of the most foundational texts on AI risk from writer Eliezer Yudkowsky. And his argument is, well, it's fascinating because it's not really about AI at all. It's about us. The whole idea is that our own brains are basically hardwired to trick us. And when it comes to something like AI, our intuition, it's almost always dead wrong.
So Yudkowsky says, by far the greatest danger of artificial intelligence is that people conclude too early that they understand it. And this really gets to the heart of it. This isn't about some evil, Terminator-style AI like you see in the movies. No, according to Yudkowsky, the real danger, the biggest one, is our own overconfidence. It's that feeling that, yeah, we've got this, only to find out way too late that we've missed something absolutely critical.
Think of it like this. Imagine there's a big red button in front of you. Now, you're not going to push a button if you know it'll destroy the world, right? Of course not. But what if you were absolutely sure, 100% convinced, that the button just turns on a light? And in reality, it does something, well, something catastrophic. See, the danger isn't malice. It's not about evil intent. It's about making that one, final, irreversible mistake, all because we're messing with a powerful tool we just don't fully understand.
Okay, so where does this huge misunderstanding even come from? Well, it all starts with this deep-seated cognitive bias. It's like a blind spot baked right into our own thinking, and it trips us up every single time we try to imagine what an artificial mind would actually be like.
And that bias has a name: anthropomorphic bias. You know what this is. It's our tendency to see human-like minds and intentions everywhere. We do it with our pets, right? We even do it with our cars when they won't start. And we definitely do it with AI. And look, it's a useful instinct for predicting what other people will do. But when you try to apply that same instinct to a truly alien intelligence, it fails. Catastrophic.
Yudkowsky points to a classic sci-fi trope to really drive this home: the bug-eyed monster. Just think about it for a second. Why on earth would some monster from a totally different planet with a completely different biology, a different evolutionary history, why would it find human women attractive? The answer is, it wouldn't. It makes zero sense. The artist who drew it wasn't thinking about the alien's mind. They were just slapping a human desire onto it without even thinking.
And this is where the true scale of the problem just becomes mind-boggling. I want you to imagine the entire space of all possible minds that could ever exist. Okay? Got it? Now, all of human thought, everything from Shakespeare to Einstein, every thought you've ever had, it all fits inside one tiny little dot. The potential space for AI minds? That's the entire rest of the map. A future AI might not just be a little different from us. It could be as different from you as you are from, say, a petunia. Our own minds, they're just not a useful reference point. Not at all.
So, okay, if we can't use our own minds as a guide for AI, that leads us right into the next huge mistake we make when we try to guess what a powerful AI might actually do. And this one has a great name. It's called the giant cheesecake fallacy. It's a fun name for a really simple but dangerous mistake. We just assume that because a super intelligent AI could do something that seems useful or logical to us, that it automatically will do it. We just leap straight from can to will without thinking about what's in between.
So let's just break this cheesecake thing down. Step 1, an AI becomes so smart it has the capability to build a cheesecake the size of a city. Okay. Step 2, therefore, the future is going to be full of city-sized cheesecakes. Woohoo! But wait a second. This thinking just completely skips the most important part, the missing step. Step 3, does the AI have any motive to build a giant cheesecake? Does it actually want to? Because if it doesn't, its capability is totally irrelevant.
So all of these problems, our biases, the cheesecake fallacy, they all funnel into what Yudkowsky calls the friendly AI problem. And this is the big one. This is the grand challenge of how on earth you build an AI whose core goals, its fundamental motives, are actually aligned with our survival and well-being. But here's the kicker. Trying to get this right is fiendishly difficult. And there are two main ways it can all go horribly wrong.
So, first, you've got what's called a philosophical failure. This is where you successfully tell the AI to do exactly what you want, but what you wanted turns out to be a really, really bad idea. Think about programming an AI to create a perfect utopia, but basing it on a flawed human idea of perfection.
You get exactly what you asked for, and it's a catastrophe. Then there's technical failure. And this one's even simpler. It's when you try to build a nice AI and you just mess up the code. And there's this famous, totally true story that shows you exactly what a technical failure looks like. Back in the day, the US Army tried to train a neural network to spot camouflage tanks in photos. And in the lab, it was brilliant, seemed to work perfectly. But then they gave it a new set of pictures and it failed completely. So why? What happened? Well, it turns out that in their original training data, all the pictures with tanks had been taken on cloudy days, and all the pictures without tanks were taken on sunny days. The AI never learned to see tanks at all. It just learned to tell the difference between a cloudy day and a sunny day. And this brings us to the urgency of it all. See, it's not just that getting AI right is a hard problem. It's that we might only get one shot at it. We might not get a do-over. And the reason for that is a concept called recursive self-improvement, or as it's sometimes called, the intelligence explosion.
To really get your head around this, there's a great historical analogy: the first self-sustaining nuclear reaction. For years, physicists were methodically, carefully building this thing called the Chicago Pile 1. It was slow, deliberate work. But then, on one specific day, they pulled out the control rods just enough, and the system hit a threshold. It went critical. All of a sudden, the reaction was self-sustaining and growing exponentially. The neutron intensity was doubling every 2 minutes. It went from a static pile of graphite and uranium to an explosive runaway process almost instantly.
And it all boiled down to this one little number: K equals 1.0006. That tiny fraction above 1 was the entire difference between a stable, inert pile and a runaway chain reaction. And the theory is that an AI that can improve its own intelligence might face a very similar kind of tipping point. An AI that gets just a tiny bit better at the task of making itself smarter could